Hello everybody, welcome to Unit 6. In this lesson we're going to be talking about classes with dynamic data. This lesson is going to combine the concepts of object-oriented programming and pointers. And we're going to talk about the special needs of a class with pointer data members. Specifically, how to define a constructor to clean up a pointer data member, and how to define a copy constructor, as well as overload the assignment operator. And of course, your learning objectives are to actually do all those things. So again, I know I harp on it, but practice, practice, practice. Our list type class would be a perfect example for this discussion. Instead of using a statically allocated array, now it has a pointer data member which will point to a dynamically allocated array. Because a dynamically allocated array can be as big as you want, now the list type class doesn't need a max constant. So here you can see our pointer to our array. We will have a constructor with one parameter max size which sets the capacity of the dynamic array. And this parameter has a default value of 5, as you can see right here. The constructor will first check and correct any invalid parameter values. So you can here check to see if it's less than 0, and if so, it sets it to 5. Otherwise, it go ahead and initializes max size to the value we pass in. Once it does that, it creates the dynamic array using that capacity and initializes the size to 0. This dashed arrow notation is shorthand notation for first dereferencing a pointer, then accessing the member's data. So you can see right here, this dashed arrow max size is the same as dereferencing this pointer and then calling max size. So this dot is the same as this arrow, except for the arrow only applies to pointers. Dots only applies to actual objects, not pointers to objects. Next, we need to add a destructor, whose name is a tilde followed by the name of the class. Just like a constructor, a destructor doesn't have any return type. Unlike constructors, though, a class may have only one destructor. And its job is to clean up any resources used by the calling object, such as deallocating a dynamic array. The destructor is called automatically by the runtime system at the end of the object's scope. So if we create a list type object, whenever it is no longer referenced by anything, the runtime environment will automatically call the destructor, which will do the deleting of whatever members that we tell it to do. Before we talk more about what special member functions such a class needs, let's take a look how it works under the current setup. Assume that this class has defined other basic member functions. So this segment of code will create a list object called list1 with a size of 5. It will insert 5 values, then print out those values. And its generated output will look like this. Next, we'll create a second object, list2, with 5 spots, and then assign list1 to it. What happens after this assignment right here? If you trace the execution of this program, you'll see that data pointer, size, max size of list2 all have the same values as list1. And that's exactly what the assignment operator is supposed to do. It's supposed to copy over the values member by member. Now, the two data pointers storing the same value means that they point to the same memory location, i.e. the same dynamic array. And this could be problematic under certain circumstances. Imagine we modify list2 by, say, removing the first 2 elements. Here we're calling remove at the 0th element, and then we're calling it again, which is going to remove the second element. We will see that list2's size is down to 3, which is correct. List1 size remains at 5, which seems to make sense as we haven't modified list1 yet. However, list1 and list2's data pointers point to the same array in memory still. So it doesn't make sense that list1 and list2 have different values. And what we see here is that modifying one object affects the data of the other object. Now list1 is in an inconsistent state. It says that there are 5 elements while there should only be 3. And this is what the program produces when it prints list 1 and list 2 at this point. And can you figure out why those values are printed for list 1? Well, here's the original list. Our call to the remove function copies the next value in memory and moves it one index closer to the beginning. It doesn't waste any resources on overwriting the locations that are no longer used. If we do this process twice, you'll end up with what you see for list 1 because it still thinks that we have 5 values stored. Now, imagine if list 2 goes out of scope and its destructor is called. What would happen to list 1 then? Well, it may crash since the dynamic array it points to has been deallocated, and that's an even bigger problem. Now that you understand the issue with copying an object that has dynamic variables, the question is, how do we fix it? Well, for a class with dynamic data, we need to make sure each object always has its own copy of the dynamic data. For that to happen, a class with dynamic data needs to overload the assignment operator and have its own copy constructor and destructor. The compiler actually supplies a default assignment operator for every class, but that one copies the address from one pointer to another instead of creating another copy of the dynamic array. And that's why it doesn't work properly in this case. This is the prototype of the assignment operator, which takes a const reference parameter and returns a reference. A copy constructor creates an object as a copy of another object of the same class. And finally, the destructor, which we've already looked at, it just has to properly deallocate any memory that was allocated by the object. So let's take a look at the overloaded assignment operator. To do that, we're going to look at the new string class that's in the textbook. It has a pointer data member which points to a dynamic char array. It has an integer variable to keep track of the length of the string. Because of this pointer data member, it needs a destructor. It has 3 constructors, a default one that takes a C string parameter, and a copy constructor. It also overloads the assignment operator. And finally, it has a private data member function to do string copying. And this is a helper function and for internal use only, as indicated by the fact that it's under the private heading. Let's first look at the implementation of the assignment operator overloading. It takes a const reference parameter of new string type and returns a reference of a new string. To do this, it first checks to make sure that the calling object is not the same object the parameter references. If it's not the same object, it starts the copy procedure. And we'll talk about why this is important in a little bit. So if it's not the same object, it starts by deleting the old dynamic array, then copies the length, allocates a new dynamic array of that length, and copies the characters over to the new array. Finally, it returns the reference to the calling object. Let's go through the copy procedure again, but a little bit more visually this time. First, we have our list object that is calling the assignment operator, in this case, string 1. And here is its member data in memory. You can see that we have its length and pointer integers in memory as well as its dynamic character array. We pass in the right-hand operand, that's the string that we're going to copy, and it occupies its own place in memory. First, we check to see if the objects are the same, and since they're not, we can delete the current character array, copy the value over from the right-hand length, allocate a new block of memory, and set our string pointer to the new blocks of memory. Finally, we do a member-by-member copy for each item in the original array. I mentioned earlier that we need to check for self-assignment before we do the actual assignment. So let's take a look at an example as to why that's important. So even though that this code is legal, if we don't do the self-assignment, this would create problems, and here's why. If we have the same code that we had before without the self-assignment check, what will happen is when we pass in the right-hand operand, which is the same as our copying object, or the object that's being copied, when we delete the string pointer here, when we try to call string copy, this guy is going to be deleted, so he no longer exists. So we're deleting the reference that we're trying to copy. So it doesn't work, right? So that is why we need to check to make sure that these two are not the same thing, so that way the program doesn't crash later on. And that brings us to the third way of how a pointer can be used, and that's to see if the calling object and the parameter object are in fact the same, right? So here we have our pointer to this, right, and we have the right-hand operand, and this is an easy check to make sure that they are not one and the same thing. We stated that we need to have three things when creating an object using dynamic memory allocation. We just looked at how to overload the assignment operator. Now we can take a look at the copy constructor. A copy constructor automatically executes in three situations. When an object is created using the value of another object, when an object is passed to a function by value, and when a function returns an object of this class. The compiler provides a default copy constructor for each class. However, as we've seen, the default one doesn't work properly for classes with pointer data members. We haven't gone over it, but I want you to try to figure out which one of these options would be the correct copy constructor. Pause the video now and see if you can figure it out. Okay, hopefully you tried to figure it out, and the correct answer was B. As you can see, the code for a copy constructor is very similar to the assignment operator, but there are some differences. First, we don't have to check for self-assignment, since we are only copying values. It's a constructor, so we haven't allocated memory yet, so there's no need to delete any pre-existing data. Also, since we're a constructor and not a function, we aren't returning anything. We're merely assigning values. So all that's left to do is to perform a deep copy of any dynamic variables. And in this case, we're using the string copy function to accomplish this. Let's take a look at our class declaration for our new string class. You can see that the class overloads several operators. First, the input and output operators are overloaded as friends. So technically they're not part of the class, but they're overloaded nonetheless. We also have the relational operators. We covered how to overload the equality operator in the last lesson, so you should be able to extend that to the other operators. We also have the assignment operator that we covered earlier in the lesson. But what I'd like to do now is take a look at the subscript operator, so you can access chars in a new string object the same way that you access an element in an array. If you noticed, we have two overloads for the subscript operator. But the question is, why do we have two? If we look at their implementations, we can see that there's not much difference. Your initial thought might have been that we need two different versions for getting and setting, since the subscript operator can be used for both functions. In fact, the reason is that our class can be declared as const and non-const, and so we need to be able to overload the function to handle both cases when accessing individual data elements. If you look at this code snippet, you'll find that these calls use the non-const version, while this call to the subscript operator uses the const version, since final string has been declared as const. So go ahead and review the code, pause it, and make sure that you understand the code snippet right here and how it applies with the implementation details of our index operator. We didn't cover all the overloads to fully flush out our new string class. In fact, we left out some key operators like the addition and compound operators. The principles are the same as what we've already covered though. You just have to think about what the operator will do and how it will access the data members and whether or not it's going to modify any data that currently exists. Stack Overflow has an excellent write-up for guidance on operator overloading. I know it's a long URL, but you can just search for it online. But here's the link right there. In summary, a class with pointer data members must, at a minimum, define its own copy constructor, overload the assignment operator, both of these things we covered in this lesson, and finally include a destructor, which was covered in previous lessons. And that's it. So if you have a class that has dynamic data, make sure that you include these things. That's it. Till the next video.